Okay, so what is uh, what is this inferential statistics? Okay, so inferential statistics is a statistical method deduces from a small representative sample the characteristics of a bigger population. In other words, it allows the researcher to make assumptions about a wider group using a smaller portion group guideline. Diba, we have already discussed census. Census is a population. So, like I said, not all researchers or not all research has wide range of resources or wide range of time. Example, or the financial stability of that certain research is not that impact. So other researchers do class is they do sample. So for example, this group of people in the population, the population, you're going to interview all of them or you're going to gather data from all of them. It requires time, a lot of time, a lot of money, access. If you wanted or you have you do not have the luxury of time, you only need to get the sample. Okay? So you get a sample from a population to make a representative population is inferential statistics. So there are two main areas of inferential statistics. First is estimating parameters. So this means that taking a statistic from sample data and using it to say something about the population parameters. For example, the population mean. To get the mean of the population based on the data gathered from your sample. This another thing, another area of financial statistics is hypothesis testing. You have already gathered the data, already make your own hypothesis, but is your hypothesis valid? So in order for that to be validated, you need to test that hypothesis. You can use sample data to answer research questions. For example, you might be interested of knowing if new drug is effective for breakfast health better in schools. So these are the different types of ideas class now that researchers thought and wanted to explore. That's why they're making researches. They're making studies. So probably one of you develop or have that idea of something and no one else thought, probably this would make a name for yourself. So this is how inferential statistics works. You have your parameters and then you have your hypothesis and then you test it. Do not test the entire population, you just gather a sample of that population. Okay? So, different hypothesis. But first, hypothesis. Okay? It's an educated guess about something in the world around you. It will be tested either by an experiment observation. For example, a new medicine you might work. Okay? Or a way of teaching you might better or might be better. Classification of new species, a fair way to administer standardized tests. If you notice in charts and glitches, this is an example of hypothesis done by ancillarius showing planetary motion. Diba? So they are already hypothesizing, theorizing on how the world rotates, how the world moves. We have night, already we have days. Other countries have longer nights and others have longer days. They theorize, hypothesize the movement of the Earth is rotating around itself. Mayroon siya rotation or revolution, kumaga. And another theory naman is that the Earth is spinning, umiikot din siya sa sun. That's why we have day. That's according to Andrea Serious, doing the planetary motion. Okay, that's how you theorize hypothesis, making an educated guess. What is hypothesis? Educated guess. Okay? So, sabi sa amin before, no? Experiment is a standard experiment or a testament if you can repeat that experimentation. For example, you done your experimentation, you had your results. And another person uh, use your procedure and develop another result. Then another person naman, same procedure, and develop another. Ibig sabihin, ang results mo not be valid because hindi siya testable. Hindi siya pwedeng mag-test or hindi siya repeatable. Experiment flow class to be validated is repeated or can be repeated by other people. Okay? So, probably mawak ka lang ng sarili mo. Diba mayroong ganun? Okay. So,
Sir,
yes,
sir, copy daw kayo, sir. Dili masabtan, sir. Sorry kayo, sir.
Sa iba? Sa iba? Same?
Medyo po tuloy sir. Po.
Sige, wait lang.
Tapos, nanonood na po kanila budulyo sir sa uhaw.
Diba? Yan ah. Okay. So, ulitin natin ha. Okay. Ito na. Ito pa tayo sa. Okay, so, by the way, so we have hypothesis testing, di ba? Hypothesis is defined as educated guess. Just making a guess based on the data you have gathered in an research, but an educated one. Okay? Sabihin, you test based on the data, information that research or the people that you have gathered and experiment. So it should be stable either by an experiment or an observation. An example of an hypothesis class is a new medicine you think might work, with teaching you think might be better, or a possible location of new species, or a failure to administer standardized test. These are all yes. Okay, hypothesis. You need to test them in order to validate this hypothesis. Okay, so an example of this is the theory or the hypothesis of planetary motion by Andrea Celarius. The hypothesis class is the way of the researchers kung bakit tayo merong umaga to have some countries have longer night or do have longer days. Bakit may araw? Bakit gabi? This answers the question. This is because probably they are debating before if the Earth revolving around the Sun is the Sun revolving around the Earth. Tayo din rotation and revolution. While umiikot ang mundo, umiikot din siya sa Sun. That's why we have night and day. The theory of planetary motion or the hypothesis about planetary motion answers those questions. Okay. By testing it and by validating it in research. And using this inferential statistics. Okay. So what is testing hypothesis? Okay. First, you need to gather data. What you have gathered is that data you have gathered will be based making your hypothesis. That hypothesis is being tested. That hypothesis is being tested by using inferential statistics. The example of inferential statistics is z-test. Z-test class is one sample Z used very often. Okay. Minsan lang siya ginagamit because we rarely know actual population under education. Most of the problems or researchers class ang population standard deviation. Some standard deviation minsan lang or walang walang population standard deviation. However, it's a good idea to understand how it works and it's so simple test you can perform in hypothesis testing. Minsan lang ginagamit si Z-test. Order for Z-test to be done or is to you to use Z-test in the population standard deviation. Okay. The Z-test is a statistical used to determine whether population means are different when the variances known and the sample size is large. Okay. Kailangan ang first reason class or the first category for you to use this is dapat malaki ang population size. Statistically speaking, dapat more than 30 ang iyong sample. Okay. First, dapat meron kang or dapat merong population standard deviation. At yung mga class, para magamit test? First, you need to have a population standard deviation. At more than 30 ang iyong population size or population variable size. So, kaya minsan hindi ginagamit si Z-test or minsan lang siyang ginagamit. Okay. So, of all statistical methods class, Z-test kasi ang pinakasimple. You see on the right side of the slide, ito yung annual formula ng Z-test. Standard deviation should be known in order for an accurate Z-test to be performed. So, hindi pwedeng walang standard deviation. Walang population standard deviation, mo pwedeng gamit si test. Okay. So, ano ba yung mga steps in doing or making or doing hypothesis testing. Okay, so first, nakita niyo ba ang slides, class? Visible ba siya?
Hindi pa, sir. White mo ang makita, sir.
Lang, no? Hindi white. Parang malaki masyado yung file. Sige lang. So, first, there are different steps, class, in doing hypothesis testing. So the first step is meron na. Okay. First step, class, is you should formulate null hypothesis, alternative hypothesis. Null alternative hypothesis. First example, title na research mo is alternative method and traditional method in finding blood pressure comparative study. Comparing alternative method and traditional method in looking for or finding the blood pressure of a human being. Your null hypothesis, class, there is no significant difference in the results from using alternative method and traditional method. That's your null hypothesis. Alternative hypothesis, class, is your there is a significant difference between results from using alternative and traditional method. This null hypothesis, class, is the one you should test, i-validate mo, i-approve mo ba or i-reject. Symbols, class, ang kanyang symbols, H, O, and HA. So the mean one is your, or the variable one is your alternative method, then equivalent to variable 2, which is your traditional method. Null hypothesis mo kasi, di ba, no significant difference. So equal, so, ibig sabihin, equal lang si alternative traditional. In symbols, ganito, symbols equivalent to variable 1 is equivalent to variable 2. In symbols naman, your alternative method, sabi mo, there is significant difference. So, hindi sila equal. So, equal sign with a slash on it, in symbol, ganito mo isusulat alternative hypothesis. That is showing equivalent ng differences, or meron bang difference or wala. Kung walang difference, equivalent. Or merong difference, yung equal sign is may slash na. That's the way symbols showing that there is significant difference between the two. So first step in doing or testing the hypothesis is you should formulate null and alternative hypothesis. Second method is need to select the level of significance. So this level of significance class. Level of significance class is also known as alpha level. Confidence level, kumbaga sa theory, di ba? Ano ba ang nito? Ang purpose ng alpha level or the level of significance? This one, class, for you, margin of error. Okay. Naman kasi lahat research, di ba? For example, you need to, for example, yung first example natin, yung traditional and alternative method. So, ano pa lang, example, three types of, by the way, we have three types of significant values of significance or level of significance. We have that 0.05 and 0.01. This is equivalent to percent, 5% and 1% margin error. Sabihin, for example, 10% lang yung margin of error or level of significance. Ibig sabihin, lumagpas ka ng 10% margin error, kailangan siyang i-reject yung null hypothesis. Pero masyado ang 10%, di ba? Ang sabi nga nila, ang usual kasi na ginagamit na level of significance or the alpha level class is 0.05, the middle of the three. Okay? 0.01 kasi ang iyong alpha significance, ano siyang mababa. Ibig sabihin, kailangan mo siyang i-read na hypothesis, masyado mababa ang alpha level mo, exact masyado namang mataas yung 10 or the 10% significance level, yung mataas. Kailangan mo namang i-reject na ang siya masyadong mataas ang iyong level of significance. Kaya of statistical method, gumagamit sila ng 0.5% level of significance or the alpha level. We're going to show you video presentation on why or what is this alpha significance or the level of significance is. Ano ba itong level of significance?
This is Stephanie from statisticshow.com. In this video I'll be showing you alpha of 0.05. You might also see an alpha level of 0.01 and sometimes 0.10. So what do these mean? Well, an alpha level of 0.05 is 5%. 0.1 is 1%. And 0.10 is 10%. But 5% of what or 10% of what? The answer has to do with something called a type 1 error and a type 2 error. This is an image of Goldilocks in a mock trial from the University of Texas. Now, the null hypothesis in a courtroom is that the suspect is innocent. So Goldilocks right here is innocent. That is the null. The alternate hypothesis is that Goldilocks is guilty. So Goldilocks is innocent, but if you reject the null hypothesis and accept the alternate hypothesis, if you make that kind of error, this is a type 1 error. If you incorrectly reject the null. Type 2 error would be just the opposite. If Goldilocks was guilty, but you let her walk free, that would be a type 2. I'm going to concentrate on the type 1 error right now, incorrectly rejecting the null hypothesis when it is true. That's because an alpha level is the probability of rejecting the null hypothesis when it is true. Here's an image of a bell curve. Over to the right, this tiny area here is our alpha level. So this is the probability of rejecting the null hypothesis when it is in fact true. This is 5%, which is fairly large in the grand scheme of things. So why not make this as tiny as possible? Why not reduce this alpha level to something pretty insignificant like 0.001%? The problem is, the smaller the alpha level, the smaller the area where you would reject the null hypothesis. So if you have this tiny area, there's more of a chance that you will not reject the null hypothesis. Even if it is false. And this would be what you call a type 2 error, or beta. In other words, the more you try and avoid a type 1 error by making the alpha level really small, the more likely a type 2 error could creep in. So the reason you see an alpha level of 5% used most commonly is because people have figured out an alpha level of 5% is a good balance between the two issues. In my next video, I'll show you how to calculate an alpha level. Check us out at statisticshowto.com for more articles and videos on everything elementary statistics.
So, naiintindihan ba, class? So, usually ginagamit si 0.05 of all statistical methods 0.05 yung ginagamit na level of significance or alpha level. Hindi nga, 0.01 masyadong mababa. So, if masyado siyang mababa for a level of significance or alpha level, dapat na hypothesis, yung hypothesis na dapat niyang i-reject, na-accept. So, it becomes a type 2 error. Meron kasi tayong dalawang type of errors sa statistical methods. We have type 1 and type. Type 1 class is either type 1 is accepting a hypothesis should be tested. Type 2 naman is accepting the hypothesis, rejecting the hypothesis that should be tested. Okay. So, the 0.1 masyado siyang mababa, saying null hypothesis to be accepted, supposed to be rejected. The point naman or the 10% significance level, kailangan mo siyang masyado naman siyang mataas. That level of significance wherein ang hypothesis pala is kailangan mo siyang accept, pero masyado mataas yung level of significance, reject. So, kaya most of physical data class gumagamit ng 0.05% significance level, alpha level. Kuha ba ang significance level? So let's proceed to top 3, no? We need to determine the test statistic used. Okay. So, like what I've said, ano mo malalaman na yung problem mo or yung research data mo kailangan ng ganitong klase statistical method. So, for example, itong kanina sabi ko, di ba? Ano mong sasabi na z-test ang kailangang statistical method? Di ba? First category natin for z, kailangan masyadong or malaki yung iyong statistical population. Ang sabi dito, dapat ang population size mo or more than 30 yung isang population. Sabi ko di ba kanina, dapat malaki ang population. And dapat meron kang dalawang variable. So we have N1 and N2. Dapat dalawa lang. Okay. Pwedeng lumagpas sa dalawa ang iyong variable. Dapat dalawa. Each variables kailangan merong 30 or more samples. Yung category for you to use the test as a statistical method. Kailangan mong ma-determine na yung iyong statistical method. You need to know your variables. Other one, we parametric and parametric. Sinabi mong parametric class, you rely on the assumptions of shape, distribution, assume normal distribution in the underlying population. So we have different types of parameters. Ang parametric class, kasi you rely on the parameters or the parameters. So for example, we have the mean and standard deviation. Usually class, parameters ang ginagamit if research mo or the data in your research are scale or show numbers. Sabihin, may value yung numbers. Parametric naman ang ginagamit, parametric test ang ginagamit, the data is nominal or ordinal. Sabihin, they rely on no or few assumptions about the shape of the parameters of the population distribution which the sample was on. Usually, data dito ordinal. Sabihin, ranking or name of sabi mo, for example, to know kung ano yung soft drinks na pinakami ang umiinom. So, that's nominal, di ba? Non-parametrics. Parameters naman, need the distribution of a sample. May parameters, may mean. Ang parametric naman, variables mo are nominal and ordinal. I think meron tayong video din how categorize parametric and non-parametric. Yes, meron.
going to look at a special class of tests that give us the ability to do statistical analyses in circumstances when parametric tests just won't do. They are called non-parametric statistics, and I'm going to tell you why we need them. From all of our studies of parametric statistics, like t-tests and ANOVA, we have learned how to compare groups using scale-level data. But what if you only have nominal data? Well, you have options. Let's imagine that we are having an end-of-semester party and we need to order soft drinks. Somebody suggests that we just buy a case of whatever is on sale because people will drink whatever is available. But you think that maybe people prefer one brand over others. So you offer the class a choice of 6 brands of soft drinks and ask everyone to choose their favorite. But how are you going to analyze these data? How can you tell if people truly have a preference for one type of soft drink or if they're simply choosing one at random? Most of the statistics that we have used so far estimate population parameters from a distribution of scores in a sample. So for example, the t-test uses sample variance as an estimator of population variance. Tests like this are called parametric tests, and they work because the central limit theorem shows us that the distribution of sample means will form an approximately normal distribution. But there is a class of tests that do not rely upon parameter estimations or distribution assumptions, and these are called non-parametric statistics. Non-parametrics are especially useful with nominal and ordinal level data, although they can be used with interval and ratio level data as well. So for example, you want to make a comparison about whether males or females are more likely to help a person in either emotional distress or physical peril. Or perhaps you want to know if patterns of soft drink consumption are the same at a state university as at a private school. Maybe you want to know if certain dormitories are overrepresented or underrepresented in their number of student government representatives. Non-parametric statistics have several advantages over parametric statistics. Number one, non-parametric tests are not susceptible to outliers the way that parametric tests are. One outlier score can affect a parametric test by inflating the variance, and hence the error term. This can invalidate a conclusion drawn by the parametric test, so you make a type 1 error, or perhaps even a type 2 error. Outliers in correlation can change the direction or the strength of a relationship between variables. But non-parametric tests do not have this limitation because they measure central tendency using ranked data. Ranking uses the median rather than a mean. So for example, if the 10th number in your distribution is an outlier, that outlier can really shift the mean when you add it to other numbers. But when you are considering ranks, it is still just the 10th number, no matter how big the actual value is. So the main advantage of non-parametric statistics is that they do not require restrictive assumptions about the distribution. For instance, they do not assume that soft drink consumption is normally distributed. Non-parametric tests can also be used when you have non-normal interval or ratio data, such as data that are highly skewed. Typically, therefore, non-parametric statistics are only used when the data are too skewed to use a parametric test. Another advantage is that non-parametric statistics are typically easier to calculate by hand, and we will practice doing some of them by hand in order to learn them. However, the main disadvantage of non-parametric statistics is that they are not as powerful as parametric tests. That means that they are more likely to miss an effect that truly exists, or that you make a type 2 error. So as you get better with statistics, you will be using mostly parametric statistics. but you should keep some tools in your back pocket that you can use at times that the paramedic.
Naintindihan ba yung parametric and non-parametric? Diba? Pag sinabing parametric class, usually the variables are ratio or scale. Non-metric naman, usually the variables here are nominal and ordinal. Yan ang titignan mo. Okay? So next, need to define the area of rejection. Okay. Kita natin kanina yung significance of value or alpha significance. Okay. Ang equivalent yan na rejection area. If you see normal distribution, example, 10, malaki yun, nandito. A. Point 10 sa kabila, and then if you're using one-tail or two-tailed. Okay. So if you notice here, yan, two-tailed dito kasi dalawa. Okay. Later on, we will distinguish ano ba ang one-tailed test, ano ba ang two-tailed. Okay. So, paano mo siya determine? Area of rejection, naman mo yan to the use of alpha significance mo. Okay. Then, kung ano ginagamit mo na signal level. Okay. And then, after noting the rejection area, you need to compute now the value of statistical test or your hypothesis. After taking your data, okay, you need to draw your conclusion. Need now to finalize your hypothesis. Either you reject your null hypothesis, accept the null hypothesis. If you accept the null hypothesis class, you reject the alternative. If you accept the accept the null hypothesis, you reject the alternative, and vice versa. Accept the alternative, you reject the null hypothesis. Hindi pwedeng both. Kaya nga siya, because ito yung kailangan mong improve. Okay? Now, the next type of taking hypothesis or the next method of inferential statistics, t-test. Okay? Test class is metric. T-test kanina, parametric din. Defines the level of significance. T-test class, pero din sila. Significant difference din ang hinahanap test. Parametric test is to test for the significant difference a small sample size. Kung kanina, z-test, ang hinap niya is significant difference of a larger population size. Or larger sample size of a population. T-test naman, small population size. Okay. That's the main difference of z-test and test. Ito nga yung t-test. Ang z-test natin kanina, dapat dalawa ang variable at more than 30 ang iyong sample size at dapat meron kang population standard deviation. Kung present yung tatlong yan, then use t-test. Okay. T-test naman, ano naman yung categories niya? T-test lang, pareho lang. Okay. Kailangan meron ka rin dalawang variable. Kailangan 30 ang iyong sample size. Dalawang yun lang ang kailangan mo use t-test. Kompleto yung dalawang yun, then you should use t-test. Hindi din kailangan ni t-test class ang standard deviation. Okay. Test, hindi kailangan ng standard deviation. Ang dalawa ang kanyang variable, dapat than 30 ang yang sample population. Okay. Now, we have two types of tests. Okay. Paired t-test, we have paired or the independent t-test. Okay. Paired t-test class, also known as dependent test, determine whether the differences between the two samples differs from 0 or a target value. Paired t-test calculates the differences with each before and after pair of measurements, determines the mean of the changes, and reports whether this mean of the differences is statistically significant. Okay. Ibig sabihin, yung dalawang variable na yun are linked together. Ibig sabihin, meron silang connection. Okay. For example, test, post-test. Okay. For example, nag-take ka ng exam and you need to know significant items your test and post-test after you have already, after your online, for example, no, nag-create for online class, then and then nag-take ka ulit ng same test, and you need to know the significant differences of the scores between the two tests. Paired test yun. Why? Because isang tao lang kumuha ng exam. It's being linked by a connection na iisang tao lang ang nag-take exam na yun. The third test. Ano naman ang independent t-test class? Independent t-test is also known as paired test. Whether difference between groups purges is unlikely to have occurred because of a random chance in sample selection. Difference is more likely to be meaningful in real. First, difference between the averages is large and the sample size is large. And respondents are consistently close to the average values, not widely spread out. Ibig sabihin, class, ginagamit si independent t-test. Yung dalawang variables are walang connection sa isa't isa. Hindi i-link sa isa't isa. For example, medical technology students grade per semester for the school year 2021. Students of GSDMSFI and students from NDDU. Okay, so testing for the grades students. Ano ang connection nilang dalawa? Wala. They are both students. Magkakaiba ang location nila or walang connection to each other. You use dependent t-test. Intindihan. Paired t-test, you use it if there's a connection. Paired t-test or independent, gagamitin mo siya if walang connection sa isa't isa kung dalawang variables. I think I have another video for this type of independent and paired t-test. Sorry. Wala pala. Wala yun. Okay, so wala palang video. Okay, next. So we have, take for example, ito siya class. Pose a sample of students given a diagnostic test for studying a particular module. So, example, no? And then again, after completing the module, yung number of students, you have 20 students. This is your prep for the module. Text before giving the module. This is the post quiz results after the module is done. So, no classing t-test ito. This is an example of paired test. Kasi nga, isang estudyante kumuha ng module at post-module, although the students yan. Mga variables, the pre- and post-module course are can instant link action. So this is example of dependent test. Ito yung kanyang solution. Okay. If you notice, sample 1 or the variable 1 is less than or equal to sample 2. Ito yung null hypothesis. Use of module does not lead to improvement. Ibig sabihin, scores ng pre-module 1 is lang or hindi mas mataas sa module na scores. Ibig sabihin, walang kwenta yung module. In other words, did they prove or did to reject the hypothesis? Alternative naman is the use of modules leads to improvement. Okay. Again, null hypothesis, use of module does not lead to improvement. It improvement, and your alternative is the use module leads to improvement. Simple class, ganito siya. So, differences. Kung nakikita nyo, may tailed. Okay, ang tailed siya. Paano mo ngayon malalaman if two-tailed ang iyong text, one-tailed or two-tailed ang iyong text? Okay. I guess I have a video for this. Do you notice, or how do you decide whether your statistical analysis is one-tailed or two-tailed?
How do you know when you're supposed to use a one-tailed test or a two-tailed test? Let's say when you're solving problems associated with hypothesis testing. How do you know? Well, in this video, we're going to talk about that. So let's say that a company manufactures potato chips, and that the average mass of each potato chip bag is 100 grams. So that is going to be the null hypothesis, where the mean mu is 100 grams. Now, let's say that an employee believes this answer to be different. He believes that the mean is not 100 grams. So this is going to be the alternative hypothesis. Now, whenever you have the situation, whenever the alternative hypothesis doesn't equal some value, you're going to have a two-tailed test. So let's draw a picture of that. So we have a normal distribution, and we're going to shade the area on the left and on the right. So this is a two-tailed test. The shaded area represents the rejection region. The area that is not shaded is the failed to reject region. Now the z-values that separate these two regions, the rejection region and the failed to reject region, those z-values are known as critical values. Now let's say that the employee conducts a test at a 95% confidence level. C is going to be 0.95. C is equal to 1 minus alpha. So that's the confidence level. Alpha is going to be the significance level. C plus alpha is 1. So 1 minus 0.95, that's 0.05, that's alpha. This is known as the significance level. So because alpha is split into two regions, the right side is going to be alpha over 2, and the left side is alpha over 2, each with an area of 0.025. The area in the middle is 0.95. Now, in order to determine whether you should reject or not reject the null hypothesis, you need to calculate the z-value and compare it to the critical value. So this other z-value, let's call it zc, this is going to be the calculated z-value, which is associated with the test statistic. If that z-value is greater than the critical value, then you should reject the null hypothesis because it's in the rejection region. If the z-value, let's say, by the way, this is the mean. Let's say if the z-value is not in the shaded region, then you should not reject the null hypothesis. You should keep it. Now I'm going to talk about how to get those z-values in another video. But for now, let's talk about the other one-tailed tests. There's two of them. So the first one would be a left-tailed test. And the second one is a right-tailed test. Both of these are one-tailed tests. Now, at a 95% confidence level, alpha will still be 0.05. So for the left-tailed test, alpha is going to be completely on the left side. Now, this is when you're supposed to use a left-tailed test. Let's say that the alternative hypothesis is that the mean is less than 100. So if it's less than some number, you need to use the left-tailed test. Now let's say for the alternative hypothesis that the mean is greater than some number. In that case, then you would use the right-tailed test. So that's how you can tell whether you have a one-tailed test or a two-tailed test. You need to look at what statement is made by the alternative hypothesis. If it doesn't equal a number, then your calculated z-values can be on the left side or on the right side, so you need to use a two-tailed test. If you believe that the mean is less than a number, then your calculated z-value is going to be somewhere on the left side of the mean, so you need to use a left-tailed test. If you believe the mean is greater than 100, then likely your calculated z-value is going to be on the right side of the mean, so you need to use a right-tailed test. So that's how you know.
Okay, so nakita na ba ninyo? Ano mo malalaman your statistical method is 1 or 2? Equal sign as alternative hypothesis. Tingnan mo lang, class. Just look at the alternative hypothesis. It is either equal or you may slash, and you are using both tailed. Okay, dalawa yan. But if you are using or yung alternative hypothesis mo, yung symbol niya is less than or greater than, nito, is greater than, di ba? Sabihin na nasa right side ang iyong one-tailed test ito. If less than naman ang nakalagay sa alternative hypothesis mo, din nasa. This is how you determine if it's one or two-tailed. Sign yan, and it is tailed. Greater than or less than yan, tailed. It's not both. Okay? And siya, applicable lang siya if dalawa yung variables mo. Okay? A variable 1 and variable 2. But if tatlo na more, inapplicable yung system. Okay? Nakita nyo, class, yung areas of region niya is 1.729. Magbibigay ka on sa based lang siya doon sa level of significance ng iyong nili. 0.5 ito, so ang kanyang level of significance is 1.729. The result of a statistical method, class, is 31. So more than the critical value rejection phase. Ibig sabihin, mas mataas kumpara doon sa sinet mo na standard. So, if ganito yung result, you need to reject your null hypothesis. Since lumagpas ka sa 1.7, then 1.729 yung result, ibig sabihin, you need to reject your hypothesis and use your alternative hypothesis. Okay? Reject the null hypothesis and accept the alternative hypothesis. The use of the modules leads to improvement. So that's your the result of your hypothesis testing. This class we have ANOVA. Okay. We have already discussed z-test, t-test, and last, ito naman yung last four significant differences. ANOVA. ANOVA is also known as analysis of variance, shortened lang. Okay? Take note of the definition of ANOVA, class is a parametric test used to test significant difference of three groups. Three or more. So kanina, test variables but more than equal to 30 and kanyang sample, dapat merong sample distribution or standard deviation. I-test naman kahit walang standard deviation or population under division, okay lang. Meron kang itong variables at dapat less than 30 ang iyong sample size. ANOVA naman, on the other hand, test, kailangan 3 or more ang iyong variable groups. And kung si z-test and t-test dalawa lang, ANOVA is 3 or more. Hindi mo ma-determine na ang isang test kailangan ANOVA-rated. Just look at the variable group. If it's 3 or more, then you use ANOVA. Metric test used to test the significant parentheses 3 or more groups. Okay, so a method of testing the equality of 3 or more population means by analyzing the sample variation. For example, we have 2 cases kasi. Sa case 1, equal lahat ng respondents in the groups. Ang 2 natin, unequal naman siya. So let's take for example itong sa gilid. This is a completely randomized design. They are using 3 types of toothpaste and forecast. But if you notice, the respondents are equal. Isa 6, yung isa 4, yung isa 5. So this is the case 2 for this 3 ang kanyang variable group. Okay, we test for that. Okay, same pa rin with t-test and t-test and z-test. See that you have 3 variable group. Okay, later on we will go in determine on how we use ANOVA sa laboratory. Okay. Let's go to Pearson R. Pearson product correlation coefficient or the Pearson R. Kanina class, test, z-test, ANOVA are inferential statistical method used to know the significant differences. Class, Pearson R or the Pearson product moment correlation coefficient is used to know the significant relationship. And Pearson R is used if meron kang variables. Daan siyang counterpart ni test and z-test. Test and z-test, dapat dalawa ang kanyang variables. Only that Pearson R is ginagamit to significant relationship. Dalawang balls. Okay. Meron din siyang our level of coefficient or correlation coefficient niya. Okay. Notice class, this is a scatter. It's how you determine if the data provided is relationship. Notice, data in a scatter is increasing. Kaya siya. Sabihin, siyang positive relationship. If naman ang data, ipababa siya, and sabihin nito class, this has a negative relation. And the third scatter plot class, if you notice, ito, okay, iba-iba lang pattern. Okay. So this has no relationship. Data provided, no relation. The next we have, for example, let's take for example ito. Or ito a study recorded hours week a cell phone and a number of letters in the last name of your and the letters of your last name. So sa problem pala, alam mo talagang walang relationship. Ang relationship, number of hours you spend using cell phone and your last name. Wala. Order for us to determine yung relationship or no relationship at all, gamitin natin ito. Okay, so your null hypothesis class is P equivalent to 0. There's no significant relationship. This is what you wanted to prove or accept. Okay? Alternative naman is hindi equal sign na may slash. Ibig sabihin, there is a significant relationship. Conduct silang relationship. You use 5% alpha. If you notice, failed siya. Why? Equal sign ang alternative is so you're using both else. And since 0.5 siya, you're using negative and positive 0.62. Beyond that, kailangan mo siyang i-reject. Diba? So, result of your Pearson R is negative 105. Pasok siya, hindi naman siya umabot yan, negative 0.632 siya. Nasa accepted region siya. So, ibig sabihin, you accept the hypothesis. Ibig sabihin, there is no significant relationship between the numbers or the time you spend on your cell phone and the letters on your texting. So, that's Pearson R. Okay? Ito naman, class, is Spearman rank. Okay? From the word self-rank. Ibig sabihin, order. Kasi sinabing order, ano nga siya? Non-parametric. Nominal, ordinal, non-parametric. Used for non-parametric test. Okay? Spearman rank correlation class, non-parametric used to find out if there is a significant relationship between two variables. Okay? So, kung kanina si Pearson R, parametric siya to test for the relationship between two variables naman, Spearman naman is non-parametric test to know the significant relationship between two variables. Okay. Let's take for example a English test. Okay. Following the number of hours you spend studying for midterm. So, rank siya, di ba? Your X is for English score, or time you spend studying, and the grade you obtain after studying for that certain hour. How do you determine for this? You need to rank. Okay. As a result, two-tailed turn equivalent siya. So your hypothesis is there is no significant relationship, and your alternative is there is a significant relationship. After you use Spearman rank test, the result is 94. Ibig sabihin, magpas ka sa iyong pumasok siya sa area of rejection. Diba? Beyond 0.614, 0.94 mo. You need to reject your null hypothesis. Null hypothesis is there is no relationship. So, since rejected sa null hypothesis, you accept the alternative, which is there is a significant relation between the number of hours you're studying to the number of scores you get from exam. So that's how you test for the hypothesis of Apollo. So next is Kruskal-Wallis. Kruskal-Wallis class is also known as the H-test. Test, non-parametric test that uses ranks of sample data from 3 or more independent population. Kruskal-Wallis class, kung si Z-test, counterpart ni Pearson R and Spearman rank, Kruskal-Wallis or the H-test is ang counterpart ni NOVA. Kruskal-Wallis class is a non-parametric test used to rank sample data from 3 independent population. Again, Kruskal-Wallis test are used if your data is A or R. If you wanted to know the relationship of a 3 or independent false class, use Kruskal-Wallis, diba? If you wanted to know the significant difference of a 3 or more independent variables, use NOVA. Okay? But if you wanted to know significant relationship of 3 or more independent variables, that is Kruskal-Wallis. Okay. Ito na yung categories na inclusive for Kruskal-Wallis. Kailan 3 or more ang iyong variables. And sample has at least 5 observation. Yun yung kailangan mo, use Kruskal-Wallis. Okay? Ito yung formula of Kruskal-Wallis. Sample test ito. So, for example, consider the examination scores of a samples of a high school student who are taught in English using these methods. Okay, so we have English test ito is 3 different methods. Method A, we have classroom instruction and language laboratory. Method B naman is classroom instruction only. Method C is one self-study and language laboratory. You notice, magkakaiba ang kanilang sample each methods, but pasok siya sa category natin na minimum of 5 per categories. We have 5 observations and we have 3 variables, so pwede natin gamitin si Kruskal-Wallis or the H test. Okay, how do you know or how do you do Kruskal-Wallis? First, again, start with doing a null and alternative hypothesis. Sabi ko kanina, di ba, kung one-tailed test and two-tailed test, matitingnan mo lang alternatives, applicable only if you have 2 variables. So ito tatlo. So tatlo siya, equal sign siya, you are using one. Diba? So alternative or analysis for this is there is no significant difference in the examination scores students in 3 methods. And your alternative naman, there is a significant difference in examination. Okay? So, how do you compute this? For first class, you need to rank them. How do you rank this course? Diba? You arrange the data from highest to lowest and then you rank them. If you notice, meron tatlong 8. So how do you categorize or how do you rank? So 1, 2, 3, 4, 5, 6, 7, add 5, 6, 7 and then divided by 3. So you have 18, divided by 3, you have 6. So 6, 6, 6 yung rank ni 80. If 5, we have 285. Ano bang rank nilang dalawa? So 7 and 9 siya. You add 8 and 9, you have 17 divided by 0.5. So 5.5 ang rank niya. 88, you have also category niya. 1, 2, 3, 4, 5, 6, 7, 8, and 11. So add mo sila, 21 divided by 2. Kasi 88 is 0.5 each with 90. Okay? So ganito pag-rank niya and you get 18 all in all for your D. So after that, punta ka sa, okay, so method A, method B, method C. Just count ilan yung data mo, 1, 2, 3, 4, 5, 6. You have 6 for method A, you have 7 for method B, and you have 5 for method C. Your rank, gahin mo lang yung rank nila galing mo. Okay? Then you put it here, and then you add the ranks. Okay? So for rank 1, you have 89.7 to 57.5, and rank 3, you have 54. You just use the formula of Kruskal-Wallis and add those two. Okay? 89.5 squared over 6, ilan sila? Plus 67.5 squared over 7, plus 24 squared over 5, and then you get the 3-year class and the 12 ounce. Okay? And the result for your H test is 9.47. Ano ba? Reject ba siya? Accepted. Okay? After you do your Kruskal-Wallis test, you get a score of 46. Sabihin, mataas or beyond just sa iyong critical value. Sabihin, you need to check your null hypothesis. Diba? So there is no significant difference and use your alternative hypothesis, which is there is a significant difference in examination if you use those three methods. I think we should end here, class, no? Because we already have 5 minutes na lang. We need to get to the laboratory pa. Okay? So any questions, sir? Tanong ba? Okay? So, by the way, class, no? Next meeting, quiz natin for quizzes is hanggang Cruzcan Wallis and yung research outline na ginawa ninyo synchronous. So that's the yung coverage ng ating quiz activity next week. After this discussion class, I am going to post 3 lecture activities to serve as your quiz. The deadline nito will be on Monday. Okay? Itanong pa ba so far? Wala na class, no? Group A sa ating laboratory after this. I need to end this conference. So, thank you everyone. See you sa laboratory. Okay?